So we've got line segments, right? Two different line segments. Well, really what that breaks down to is two different integrals summed together. Okay? So you integrate over one line segment, and then you integrate over the other line segment, you add them together, and then that's the full value of the integral. Okay? So for instance, just in a shorthand notation, if you parameterize this and call it C1, so this guy and this guy make C2 altogether, right? Okay. So what we're saying then is the integral over C is the integral over C1 union C2, and that's additive over disjoint line segments, or distinct line segments, that is. That's additive. So that'll be the integral over C1 plus the integral over C2. By the way, you're not allowed to use that notation. You can only skip notation once you get a bachelor's degree in math. Or better, right? So don't be showing me this kind of stuff. This is for you guys for understanding, but don't be showing me that kind of, this is bad notation. Let's make no mistake about it, right? I'm leaving off a bunch of stuff. Okay, so 0, 0 to 1, 1. So, okay. That would be this line segment, right? And then from 1, 1, so we start where we left off, from 1, 1 to 2, 3. So from 1, 1 over to 2, 3 up here. And so I'll do this other segment in yellow, I guess. So this guy is C1, and this guy is C2. Okay. So what would be a good way? We need parameterizations. So what would be a good way to parameterize C1? In other words, we need our parametric equations, right? X, Y. Well, yeah, because if you think about it, the line in red is given by the equation y equals x, right? Everybody agree with that? It's going from 0, 0 to 1, 1. So just let x equal t, and then automatically y equals t. What would t have to range from? 0 to 1. And then C2. Now, C2 is created by the line segment from 1, 1 to 2, 3. So one way to get the line for it is using your good old slope, not slope-intercept form, but point-slope form. Y minus y1 equals m times x minus x1. To get just the equation, remember algebra, just the equation of the line? So what's the slope? Yeah, the slope, if you take 3 minus 1, that would be 2, right? So 3 minus 1 is 2, and then 2 minus 1 is 1, so 2 over 1 is your slope, right? And then let's call 1, 1 my x1, y1. So this would be y minus y1 equals m, which is 2 times x minus x1, which is 1. Everybody see that? So this is y minus 1 equals 2x minus 2 if I distribute this 2. Add 1 to both sides, what do you get? Y equals 2x minus 1. So couldn't you let x equal t? And then automatically, what's y? 2t minus 1. Now, what we have to find the bounds on t. What t value generates this first point here? So definitely 1, right? If you double check, if you plug 1 in here, you need to get 1, 1, right? You plug 1 in here, you get 1. Plug 1 in here, you get 1. Okay, and then you need to get 2, 3. So what value would generate 2, 3? So 1 to 2. Make sure, okay, x equals 2, y equals, when I plug 2 in here, 2 times 2 minus 1, yeah, it works. Okay? So what you're going to do is you're going to set up two separate integrals based on these parameterizations. Okay? Let's take one at a time. So let me move this guy. And let me get this guy out of the way. Okay. So, and then this was extra junk. It's not an exponent. Okay. So, setting up the first integral then, according to this, let's just start plugging in and find differentials as we come to them. So it'd be the integral from 0 to 1 of what? X plus y would be 2t, right? And then what would dx be? 1 dt, right? Yep. And then plus x times y, what would that be? T times t squared. dy, what's dy? No, y is equal to t, so dy is dt also. And that's your first setup. Remember, just factor out the dt and you've got your single calculus 1 type integral. Okay? That's your first setup. And then for this one, we're filling in the same formula, right? So what's x plus y? Integral from 1 to 2 this time. X plus y would be what? T plus 2t minus 1. So 3t minus 1. And then then dx would be, in this case, the same thing, right? dx is dt. And then the second part, x times y, dy. So plus t times 2t minus 1. And then what? dy is a little different here. What's dy? 2 dt, right? So 2 dt. There's your second setup. Does that make sense? So let me get it so you can see everything at once. Is that okay? Everybody see what I did? Everybody see I'm just very carefully substituting to set it up and then finding differentials as I need them. Of course, I have to define my x and y in terms of t. But after that, it's substituting. And you got to be careful with your algebra. But now, again, on both of these, you factor out the dt, combine like terms, multiply out if you need to, combine like terms, and you've got just a single integral with respect to t. Now, what do? Once you evaluate both integrals, add them together, and that's your integral. Okay?